Welcome to lesson number 2, applications of prime factors. First thing that most of these chapters begin with is a little bit of a review. So we want to express the numbers 48 and 72 as products of prime factors. If I start with 48, there's two ways we could do it. We could either do the tree diagram or the division table. But if I start with a tree diagram, 48, I could break down into 6 times 8. And breaking it further, 3 times 2 times 2 times 2 times 2. And as products of prime factors, 48 would be expressed as 3 times 2 to the power of 4. 72 is 8 times 9. And 8 can be broken down to 2 times 2 times 2, whereas 9 can be broken down to 3 times 3. And so 72 can be expressed as 2 cubed times 3 squared. That's what we did last lesson. This lesson, we're going to be looking at the greatest common factor. What is the greatest common factor? Well, the greatest common factor of a set of whole numbers is the largest whole number which divides exactly into each of the members of the set. So, for example, the greatest common factor of 8, 16, and 20 is 4. 4 goes into 8 twice, goes into 16 4 times, and goes into 20 5 times. I'm going to do just one example for saying the common factor of A, B, and C, class example number 1. So if I say the greatest common factor of 15, 25, and 35, that would be equal to 5. And the 5 goes into 15 3 times, goes into 25 5 times, and 35 7 times. So in these examples, there are some that get a little bit more complicated, right? Like 48 and 72 is an example. And sometimes what we're going to have to do is we're going to have to break it down into the prime factorizations. So breaking it down into the prime factors. 48 and 72, we broke that down to the prime factors earlier, but if we focus on the ones that are common, 2 times 2 times 2 times 2 times 3, so 2 to the power of 4 times 3, or sorry, that's 2 to the power of 3 times 3. So our common factor here would be 24. So 2 to the power of 3 is 2 times 2 times 2 times 3 is equal to 24. So 2 times 2 times 2 times 3 is equal to 24. Now, if we use the same method of breaking it down into the prime factors for class example number 2a, we're going to break down 90 and 225 into their prime factors. And again, I'm going to do this by using a factor tree. So 90 can be broken down to 9 times 10. And if we break these down into the prime factors, 3 times 3 times 5 times 2. And with 225, the same thing, we're going to break this down. Nine times 25, and we can break this further down into 3 times 3 times 5 times 5. And as I break these down into their prime factors, I'm just going to circle the ones that are common between these two numbers. So 3 times 3 times 5 and 3 times 3 times 5. So 9 times 5 and 9 times 5, which means that my common factor is going to be equal to 45, and again is going to be equal to 45. So next we're going to look at using prime factorization to determine the greatest common factor of 245, 315, and 770. So 245, 315, and 770. You're probably going to want to allow a little bit more space, so I'm just going to cross this one out here. I'm going to write it over here, 770. Now, when you end in 5, as all of these do, if we're making a factor tree, I know that my factor tree here is going to be divisible by 5. So if I divide 245 by 5, I'm going to end up with 49. And 49, 7 by 7. 315, again, if I divide this by 5, I'm going to be left with 63. And 63, 7 and 9, 3 and 3. And I'm left with my prime factors. 770, I'm going to divide this by 10 because it ends in a 0. And I'm left with 77. And my 5 and a 2. And a 7 and an 11. So the next thing we want to do, circle all of our common prime numbers. So I have a 5 and a 7 here, I have a 5 and a 7 here, and I have a 5 and a 7 here. Now 5 times 7, I'm going to be left with 35 is my greatest common factor. So my GCF is 35. Now another concept we're going to look at is the lowest common multiple. So when we're looking at the lowest common multiple, this is different than the greatest common factor. Sometimes this will be known or referred to as the LCM. As an example, multiples of 6 are 6, 12, 18, 24, 30, 36, 42, 48. Multiples of 8 are 8, 16, 24, 32, 40, 48, 56. And what we're looking for, common multiples of 6 and 8 are 24 and 48. But what we're looking for is the lowest common multiple. So if I'm looking at 6 and 8, 12, 16, 18, 24, 24, the first time we see the same number, the common number between 6 and 8 appearing is right here at 24. There are others, right? There's 48 as well, but the lowest common multiple is 24 because it's the smaller of 24 and 48. Now what we want to do is determine the lowest common multiple of the following. And again, I'm just going to do class example 4A here. So 5 and 7, what we would do is we would begin by making a list. So 5, if I start with all the multiples of 5, I have 5, 10, 15, 20, 25, 30, 35. With 7, I have 7, 14, 21, 28, 35. And here I have my lowest common multiples. So the lowest common multiple between 5 and 7 is 35. Now, in this above example, parts A and B were fairly simple, and part C is a little bit more complicated. If you want to try this one, it's a little bit more complicated. So prime factors can be used to simplify the solution. So again, getting these into the prime factors you might find is a little bit easier. So with 10, they got this value to 2 times 5, the prime factor. 12, they got down to 2 times 2 times 3. And 14 to 2 to 7, 2 times 7. So when you're getting those down into the prime factors, to determine the lowest common multiple, you take all the prime factors of one of the numbers and multiply by any additional factors in the other numbers. So as an example, we have 2 times 5, and an additional factor that appeared was 3, and another additional factor that appeared was 7. And we use 2 again, because if we don't use 2, then we don't end up getting a common multiple. So if we multiply 2 times 5 times 2 times 3 times 7, we get our lowest common multiple between 10, 12, and 14, and that is 420. Now, if we were to use that method, it's not going to appear until class example 5C. And so let's take a look at 5C and how we would tackle this one. So again, we simplify our prime factors into the lowest common multiples. So 22, we're going to isolate down into its prime factors. So 22 is going to be 2 and 11. 154, if we divide this by 2, we get 77, and we can make this a little smaller. We have 7 and 11, and then 198. We divide 198 by 2, we get 99, and we get 9 and 11, and we get 3, 3, and 11. So the first one we want to do is to determine our lowest common multiple. We would take our values, so 2 times 11, we'll throw in the 7 as well. Well, in this case, we don't really need to throw in the 7, because if we look at the 11 that's appeared, we know that 22 is not divisible by 7. And so this one was actually a little bit easier. Our lowest common multiple here is going to be 11. Or actually, it's going to be 22. Sorry about that. Yeah, our lowest common multiple here is going to be equal to 22. If we look at all these 2 and 11, they're all divisible by 22. Now, the last thing we're going to be looking at are perfect squares. Perfect squares in grade 10 and after grade 10 as well in grade 11 and 12 are going to be really helpful if you start memorizing your perfect squares. So perfect squares of whole numbers include 1, 4, 9, 16, 25, 36, 49. Every perfect square has 2 square roots. One of them is going to be positive, whereas the other one is negative. The square root, which is positive, is called the principal square root. The principal square root of each number is, and the numbers given above, so 1 corresponds to 1, 2 corresponds to 4, 3 corresponds to 9, so forth and so on. We're only going to be looking at the whole number square roots, and that means we're only looking at the principal square roots. So in this example, we want to complete the prime factorization of the following perfect squares: 9, 36, 49, and 64. So 9, we have a 3 and a 3. 36, well, 4 times 9. 2 and a 2. 3 and a 3. 49, 7 times 7. And 64, 8 times 8. So the square root of 9 is 3. The square root of 36 is 2 times 3 is 6. The square root of 49 is 7. 7 times 7. And 36, we have 3 times 3. 64 is equal to 8 times 8. And the square root of 64 is 2 times 4 times 2 times, let's see, what are they doing here? 2 times, oh, it must be going 4 and 8. Sorry about that. 2 times 4 is 8 times 8 is 64.